Okay, so in the last video we will discuss this theorem, that is, if a graph G with E edges are there and if n vertices are there, then we have to prove that the summation of the degree of all this vertex is 2 times the number of edges. Fine. So this is what we were done in the last class. So here now we have the next theorem, that is the number of vertices of O degree in a graph is always even. So to prove this to prove this theorem, but we have to understand what the theorem says first. First, it is said that the number of vertices which is having the odd degree is even. So that means we know for a graph G with V vertices and E edges, we have this. Now the vertex V can be grouped into. So V1 is a set of vertices with even degree and V2 is a set of vertices with odd degree, let us say. So the total V means what? The total V means V1 union V2. That is, the total V means the union of V1 and V2. V1 means the vertices with degree even and V2 is the vertices with degree odd. Fine. So if you am doing V1 intersection V2, do we have anything? No, we won't have anything. We will have just null. That is because V1 is the vertex with even degree and V2 is the vertices with odd degree. There would be nothing common in it. The proof that we have to do is that our goal is to prove that this vertices with odd degree, that is V2, the number of vertices of the vertices, that is number, let us say we can represent the number as V2 like this. Okay, so the number of vertices V2, we have to prove this number to be even. The number that we get by calculating the total number of vertices with odd degree, that we have to prove to be even. That is our goal. So this is how we are going to first say the setup. We have a graph G with vertex V and number of edges E, right? We will first say it like this. Then we will say, then what we are going to say? Then we are going to say V1 and V2 we are going to consider. V1 is the vertices with even degree and V2 is the vertices with the odd degree. Now if we have V is equal to V1 union V2, what does it do? V1 union V2 will do what? Their union, if you do, we get the same vertex V itself. So and also their intersection V1 intersection V2 is what? It is null. There is nothing common in that. This is how we are going to first initialize it. Fine. Now we are going to split our degree. We are going to split our degree sum. That is, here if we see the total summation of the total vertex with the total degree of all the vertex, if you do the summation, it is the degree of the vertex with even degree and degree of the vertex is the odd sum. We can split it like this also, that is, if V1 is the vertices with odd degree and V2 is the vertices with V1, let's say the vertices with even degree, that is what we have considered in earlier slide, and let's say V2 is a vertex with odd degree. So if I'm taking the summation of degree of V1, that means that if I'm having total number of even vertices, all these even vertices degree and the summation of all the odd vertex degree, this will give me all the vertices degrees sum. Okay, this is the V. This V would belongs to this V1 set. V1 set means what? The even degree set, vertices set, and V2 is the odd degree vertices set. So if I'm taking the degree sum of V2 and V1, I'm getting this. And by the previous theorem, I have proved that the sum of the whole, this is also known as handshaking lemma, the theorem that we have proved earlier. We have already proved that theorem in the previous video itself, that is the sum of degree of all the vertices is 2 times the number of edges. So that means in this side of the equation you will get 2 times of E, which is actually even. This we will get, and we know, and so here from this side we will get, that is, here this would always have an even. This means this side is always even. And the sum of the degree with even vertices is also even. This we have already, this is something which we know, right? The even, if I'm taking the summation of the degrees with even vertices, that is even degrees summation if I take, that is even numbers if I'm adding together, I'm getting an even number itself. So this will be even. Now we have to see what would be this value. So if this is even and this is even minus even is what? If I'm having 2 minus 2 is 0, it is an even number. Okay, 4 minus 2, it is an even number. So you have to understand that if I'm subtracting an even number with an even number, I always get what? Even number. Try with anything. 100 minus, let's say 98. What do we get? 2. Whatever you do, even minus even is always even. So that means this would be always even. That is, the degree of the vertex sum must always be even. So we get, that is, odd vertices sum, odd vertex degrees sum, I'm getting an even. Odd plus odd, I'm getting an we know odd plus odd is even and odd plus odd is odd. That means here degree of vertex, the total degree is what? The total degree, the odd vertices degree is an even number. That means finally you will get an even number here when you add all the odd vertices. That is, if I'm adding odd numbers, if I'm having odd numbers, if I'm adding the odd numbers, that odd numbers, let's say I don't know how many odd numbers I have, that is what we have to find, the number of vertices with odd degree we have to find. But if I'm adding all these odd values, I'm getting an even. See, if you see 3 plus 3, I'm getting 6. This we know. If I'm doing 3 plus 3, what I'm getting 9. So if I am adding even number of odd values, then only I will get an even number. If I'm adding odd values, that is, if I'm adding 3 times 3, that means I am adding this odd number odd times I am adding it, then I will get an odd number. But we are adding these odd vertices, odd degree values, and I am getting an even number. If I wanted to get an even number, that is, this degree can be even or odd, right? When this degree can be even or odd, if the number of vertex, V2 means the V2 with mod means the number of vertices of V2, that is the number of vertices with odd degree. If it is even, then only it will give me even, that is the number of vertices with odd degree. The total in my graph, if I even number of odd degree vertex only, I am going to get the summation to be even. So that means my V2 should be equal to even, that is the number of vertices with odd degree should be even to satisfy this condition. So we can say that V2 should be even for this thing to work, that is number of vertices with odd degree should be even, then only we can get their sum to be an even number. We have found that the degrees sum is even here. If the sum need to be even, what is the condition? The number of vertices with this odd degree, the degree sum is even, then how many vertices should be there? The number of vertices should be even, then only we can get an even value here when we are adding. But if you see, when I'm adding even number of times the odd values, I'm getting even. But when I'm adding it odd number of times, then I'm getting an odd value. So if I wanted to get an even value, then it is what? Then it should contain even number of odd vertices. Then only their summation can give me an even number. Understood? So this is our conclusion. So finally we have proved this. Finally we have proved that their sum of the odd degree vertices in a graph is even. Okay. How we prove? First we said that LHS is 2e even. And we know sum of even numbers is always even. So this is also even. So if even minus even, this would become what? Even itself. So if this term has to be even, then the number of this vertices in it should be what? Even. So we proved the number of vertices should be even. So that is what here you can see V1, V2, V3, V4. We have different example. V1's number of degrees 1, V2 is 3, V2, V3 is 1, V4 is 1, their degree. Okay, these are all odd degree. So if I'm doing the odd degree sum, like 1 plus 3 plus 1 plus 1, what I'm getting? 2, 5, 6. I got 6, which is what? What is this 6? This 6 is, when I'm doing the sum of this, I got a 6, which is an even number. So when did I get this even number? When my number of vertices is 4. When I have 4 vertices with odd degree like this, I got an even number. So the number of vertices should be even. Here 4 is an even number. When I have the 4 vertices, odd degree vertices 4. When I have 4 vertices with odd degree, their sum I get it as even. Their sum here, this is a sum. This sum I got it as even. When did I get this sum even? When my number of vertices is even. If I'm cancelling 1 from it, let's say V4 is not there. Now if I'm adding all this degree, 1 plus 3 plus 1 is what? 2, 5, 5, which is an odd number. When I am doing the degree sum of odd numbers, like 3 only, which is odd number, I'm getting an odd number. But here our condition is that we need to get an even number. So if I wanted to get even number, the number of vertices should be what? 4. Then only I get here an even number. I hope you have understood. If you have any doubt, please write in the comment section. Thank you.